This is a pre-built application. So if I go ahead and run it, you have three options, either to train or to run or to exit. So if we run, we have a big difference between the actual result and the target result. So let's go ahead and do some training and now run it again. So here we go. The actual result and the target result are now very close. So what we have here is a neural network of 5 neurons. 2 of those are in the input layer and 2 are in the hidden layer and 1 is in the output layer. And the I indicates input, the H indicates hidden layer, and the O indicates output layer. And those are the 2 weights in this neuron, and this is the threshold for this neuron. And so each neuron has 2 inputs and a threshold. And here the adjusted error is smaller than the current error. So we go ahead and proceed. And this is the same case, and this is the same case. And here the adjusted error is bigger than the current error. So we take a look at the probability number and the random number, and the random number is bigger than the probability number. So we hold. So we have the same weights and threshold here. And here we have the adjusted error is bigger than the current error. So again, we take a look at the probability number and the random number, and the random number is smaller than the probability number. So we go ahead and proceed, etc. until we get to those weights and threshold for the neural network. Now we have also this temperature, and it is used in the formula for how we proceed or we hold if the adjusted error is bigger than the current error. So when the temperature is high, we can proceed more often, and when the temperature becomes low, as it gets lower and lower, we do more holding. This is the same idea as in annealing. So when the metal is hot, it's easier to manipulate. When it gets colder, it becomes much harder to manipulate. I will start by creating a new project. And here I will have a neural network class, and it will be in this package. And the neurons in this neural network will be either in the input layer or a hidden layer or the output layer. And we will have 2 neurons in the input layer and 2 neurons in the hidden layer and 1 neuron in the output layer. So the total number of neurons will be 5. And we will also have a neuron class, and a neuron will have a threshold and two weights and an output, and it will belong to one of three layers: the input, the hidden, or the output layers. And we will have get and set methods for the threshold, the weights, and the output, and a get method for the layer type. And we will have a simulated annealing class where the simulated annealing logic will be. And an application driver class with a main method. Now the neuron class will have two constructors. One that instantiates a new neuron given what layer it will belong to, and another one, it will instantiate a new neuron given a threshold value and the two weights and what layer it belongs to. And we will be using the log sigmoid transfer function. So 1 over 1 plus exponential of -1 times the weighted sum that is passed in here. And we will have this method that instantiates a new neuron and populates it with the adjusted weights and threshold of this neuron and returns that new neuron. So this should do it for this class. Next, let's go to the neural network class. And here we will have an array of neurons, of all the neurons, the input, the hidden, and the output neurons. And get and set methods. And this class will have two constructors. One that instantiates a new neural network given a passed-in array of neurons that is used to populate this array of neurons. And the second constructor will instantiate a new neural network with two input neurons and two hidden neurons and one output neurons. So here 0 to number of input neurons and number of input neurons to number of input neurons plus number of hidden neurons. And each neuron will be initialized to a random threshold and two random weights. And I will have XOR training data defined here. So if we have 0 and 0 or 1 and 1 as inputs, then the target result will be 0. And if we have 0 and 1 or 1 and 0 as inputs, then the target result will be 1. And here let me define this run method. Let's return 0 for now. So it takes in the input coming from here. And I will have this calculate root mean square error that would calculate that error and return it. So run here would return the actual result, and here we are going through all the training data, and here we subtract the target result minus the actual result, and we square that, and then we add all those up for all training data. And we end up with local errors, and then we divide the local errors by the training data length, and we do a square root for that. And this will be the code for the run method. So we go through all the neurons, and we check if it is an input, a hidden, or an output neuron. If it is an input neuron, then we set the output for that input neuron to be what's coming in as input from the training data. And if it is a hidden neuron, then we add the threshold of that neuron to the weighted sum, and then we go through all the neurons, checking which one is an input neuron, and we pick up the outputs of that input neuron one at a time, multiplying them each time by the weights of this neuron. And we end up with a weighted sum that we pass to the apply activation function. And in case we have an output neuron, we do the same thing, except here we are checking if we have a hidden neuron. We go through all the neurons, and we check if it is a hidden neuron. Then we pick the output of that hidden neuron, and we multiply it by the weights of this neuron that we're looping through. And then we end up with a weighted sum that we pass it to the apply activation function. And this run method returns as a result the output of the output neuron, so number of neurons minus 1. Now going to the simulated annealing class, let me define this rate of cooling and this initial temperature, and I'll set the starting temperature to be the initial temperature, and we'll define this minimum temperature. And let me define those two printing methods. So this will print the heading, and this method will print the rows below that heading. and I will have a public anneal method that is called in order to perform simulated annealing on this neural network. And I will have this private adjust neurons method that takes in a neural network, and we go through each neuron in that neural network and call the adjust method on it, and we put those adjusted neurons in this neuron array, and we do a set neurons on the neural network, and for convenience return the neural network that was passed in here. And here I will first print the heading, and then go into a while loop. So while the temperature is bigger than this minimum temperature, and the temperature will start from the initial temperature, we will use this formula to decrease the temperature. So the new temperature is equal to the old temperature times 1 minus this rate of cooling. And inside this while loop, I will start by picking up the current error by calling calculate root mean square error on this neural network that is passed in. And I will also pick up the adjusted error by calling this adjust neurons method and calling the calculate RMS error on this neural network, on the adjusted neural network that is returned. And if the adjusted error is smaller than the current error, then we will go ahead and proceed. So let me define this string buffer, and I will append to it this proceed message. And here let me pick up the neurons on the passed in neural network, and I want to keep track of the current network. So here the neurons will be what's returned from neural network.get neurons, especially since here we called adjust neurons on the neural network. And the current error will be the adjusted error. And let me define this method that is used in case the adjusted error is bigger or equal to the current error, so in the else case here. Let's for now return false. So I will do an else statement here. So if this method returned true, then we will proceed. So the neurons will be what's returned from neural network.get neurons, and the current error will be the adjusted error. And here I will set the neurons and print the current row, so while going through this while loop. And this will be the logic for this method. This is the acceptance probability formula that I am using here, and this number is for convenience. So the idea here is the same as in the annealing process. So in the annealing process, as the temperature decreases, it becomes more difficult to manipulate the metal. So here, as the temperature decreases, we will increasingly do more hold than proceed. So we get a number from the formula, which would be the probability number, and we come up with a random number. And if the probability is bigger than the random number, then we set the flag that we will be returning to true. And if it is true, then we print out the proceed message, random number smaller or equal than the probability. Otherwise, it defaults to a decision of holding random number is bigger than the probability. And we end up appending the decision to the passed-in string buffer, and we return the acceptance flag. So this should do it for this class. And next I will go to the driver class, and here let's start by defining this printing method. It will print the result of running this neural network, and I will be using a buffered reader to pick up what the user is entering on the command line. So we will have a while always true loop, and here we will start by prompting the user. They can either enter train or run or exit, and we will read what that user entered. And in case they entered exit, then we will break out of the while loop and exit the application. Otherwise, if they enter train, then I will instantiate a simulated annealing instance, and let me define a new neural network here. So I will instantiate a new simulated annealing instance and call the anneal method on it, passing in this neural network. And if the user wants to run the neural network, then I will define this result array that will contain the result of running this network, and then I will pass this result to the print result method. And actually, instead of 4, so we have 4 here. So instead of 4, let's enter training data.length. So here we will find the result of each one of those inputs. And this should do it for this class. Next, let me go ahead and test run the application. So let's try to run it first. And we have a big difference between the actual result and the target result. So let's try to do some training and run it again. And here we go. So the actual result and the target result are now very close.